We're currently working on adding animation to our character, and currently we are instancing the animation, and this is being instanced every single frame. This means that essentially we are duplicating the character every single frame, and this is something which we do not want to happen. The other thing that we want is we want for our entity to be driven by this animation. In this case, we're not going to be using the entity to place the animation. Instead, we're going to be using the animation to place the entity. This is not always the approach which you'll want to take, but in my case, I'm mainly going to be working with root motion, so I'm making that assumption at the start. This means we can work around the limitations and problems of root motion from the start as well. So we can take a look at our script again. We're creating an entity buffer. We're going to use this to process the instances of our entity, and this buffer should be processed at the start of every single frame. We're going to set up this entity in our for loop, and this is where we'll add all the information that needs to be processed for this entity to this buffer. So the entity that we are instancing is the animated mesh, and we will want to perform operations on this mesh, so we will need a reference to this. Specifically, I'll want to have references to its transforms. Currently, we are not storing any of this information, so I'll need to create some components in order to store this. So I'll go to my component script and we'll add the components here. I'll set the first of these to be a public class, GameObjectTransform. This will inherit from iComponentData. This will have a public transform which will be called transform. Next, I want a reference for my animation. This will be public class. I'll call this GeoAnimator, as this will be referring to an animator game object. This will also inherit from iComponentData. This will contain a public animator, and the variable name for this will be animator. That will give us our components, and these components can now be referenced within our system, and in this case I want to reference them within the player system. I'm going to add these components to our entity command buffer, so this will be ecb.addComponent. The component that we'll add will be the GameObjectTransform component, and I'll initialize this with a new instance of a GameObjectTransform. We will then set the instance of this, so we'll set the transform value, and I'm going to set this with the instance of our GameObjectTransform. However, I do not want the transform of the game object itself. I want the transform of the child, which will be the animation itself. The game object will be the transform for the prefab. Its first child should be the transform of the character. This is not necessarily the best way of approaching this, as it is completely reliant on the current structure that I have, and if this changes it will break, but it will work for now. So I'll get this with GameObject.transform.getChild with an index 0. However, we don't need the child, we need the transform. So this will be .getComponent, and we're going to get the transform from this child. I'll then need to get an instance of the animator. So this will be ecb.addComponent. I'll add a GeoAnimator component. We're going to be setting our animator on the component, and once again I'll get this from our game object. In this case there will only be one animator in all of the children, so I'll retrieve this with getComponent in children, and the component that we're going to look for is our animator. So we're now creating an instance of our game object, and we're storing its animator within our buffer, as well as our transform. I'll then remove a component from our buffer. So this will be ecb.removeComponent, and I'm going to remove the instance of the prefab. This should mean that the prefab is only updated at this frame and is not retained later on, and this should stop the ghosting of our animation. I can now return to Unity and we can test this. We should now only have one instance of the animation, and we should see our character moving forward. So next I want to apply this animation to my entity, so that the entity moves along with the animation. So I have a for each loop. The variables will be animator and transform, and I'll test if these are in systemapi.query, and here we'll query for the animator, so GeoAnimator, and our GameObjectTransform as well. These can now be used to update the animation that we're using. We currently have a variable driving our animator, and I'll create an equivalent here. This will be a variable called speed, and this should be a float variable. I'll set this using a math.length squared function, and I'll set this with my right stick .value. This is not a particularly good setup, and I could probably actually drive this from the value itself. However, this is a vector, so I want the length of the vector, not the individual axes. The main purpose here is to make sure that I'm getting a value based off my controller. I can then use this value to update my animator. I'm storing my animator component in the variable animator. This will have a reference to my animator, and I'll access this with .animator. And I'll set the speed value in this with setFloat. The name for this value is speed. I should probably use a hash here, but I'll worry about that later. I'll set the value of this with our speed variable. So now we're controlling our animation. And the next thing that I want to do is get the transform from this animation. I'll need a variable to store this in, and this will be a float3, which I'll call current position. I will initialize this with a 0 vector, so this will be initialized with float3.0. I'll set this current position from my transform. Current transform equals, and we'll set this with transform.transform.position. So this should store the position of the animated character. I can now update the for loop where I'm updating my entity. I will comment out the line where I'm updating the position. Currently this is setting the position with the input, and instead of using the input, I'll use the current position. This means that the animation should now be driving the position of the character. I can return to Unity to test. I'll press the play button. When I press forward, the character is walking forward, but the camera should now be moving along with the player, and the camera should rotate around the player. I do have a small issue which is hard to show specifically, and that is there is a delay when I stop my animation. If I enter the animator window, I can take a look at the transitions. Here we'll see that there is a checkbox which is has exit time. I'm going to turn this off for both of my transitions, as currently the entire animation has to finish before a transition is made. I want the transition to be initialized during the animation. Updating this fixes my controls. I now have the animation being driven by my controller, but I also have my camera moving along with the player. So we've got the initial control and we've got our animation. We now want to be able to blend between animations in order to drive our character, and we'll start working on those next.